Well, today I'm looking at this thing here. It's a ZOYI/ZOTEK thing. This one's a battery test multimeter. So I showed this in the mailbag recently. So there'll be links down below for this. This has been sent to me at no cost by ZOTEK, so make sure you check that out. So we've got a thermocouple lead, got a multimeter probe, standard PVC lead, very thin actually, surprisingly thin. It's probably voltage only, so it probably doesn't matter so much. And then we've got a resealable bag, and obviously a USB-C charge cable, and a manual which we'll look through very quickly. Well, you can look through it, I'm not going to read it. And then we've got a little bag with the actual meter in it. We've got all these accessories and the meter, and you've got a bag to put the meter in. What about a bag for the accessories? What are you supposed to do with these? Shouldn't there be a bag that all the stuff fits into? You know, one of these little cloth bags that's like, okay, that protects the meter, but really I think it should be a proper bag which all this stuff fits into. They're not expensive to buy. You can get them off AliExpress yourself if you really want to, I suppose, but if you're buying something like this, you really expect it to be keeping all the accessories together. I'm being really critical today. So that's a negative thing sorted out. Hopefully there's no more. Todding bale, yeah, no, don't like that. These always feel a bit too weak to my liking. I don't know. I mean, can I push buttons? Barely. I can. It doesn't help that my desk is quite slippery, right? So this does want to slip away. If you want a better service, say if I actually put it on a bag like that, for example, it'll probably be fine, right? It doesn't want to slip. Okay, the bag wants to slip on my desk, but the bag itself, it doesn't want to slip on that. Obviously, it depends a lot on the service you're using, but to me, a toddling bale should support it without flexing. So this thing here, it has a little plug over that to keep the dirt and stuff out. It's nice. 4-wire connection. Yes, it's 4-wire. So this thing does battery testing and multimeter functions, which was called a battery test multimeter. That's why they call it that. Haven't powered this up yet. I've got no idea what this is like. Let's do a screen pull. Actually, I'm going to hold you off on that one. You have to just hold on there. We'll look at the manual first. Have a quick flick through this. Right, let's do the boring bit. Get this out of the way. Use a manual. At least it's a printed manual come with it instead of something you have to scan. Overview. Read these yourself. Just pause the screen at any page you want to read. I'm not going to read it. You can read it. As always, I'm just going to fumble my way through and see what I can figure out by using it, which is how I like to learn to use things. I just like to try and figure it out as I go. Oh, okay. There's a little chart there for battery internal resistances to give you a guide about what you should be expecting to see. Same thing on that side there. Nice. So it's got resistance, continuously, diode test, capacitance, temperature, firmware upgrade. Yep, you can do that too. Battery charging. Yep. Technical specs: 25,000 count, auto and manual range selection. Okay. True RMS. Yep, it's pretty common these days. 2,000 mAh battery built in. Alright. Actual specs we care about here. So 25,000 count means you only get 25 ranges, like 2.5 and so on. 0.05% plus 3 counts for each one, you reckon? Across all of those. And normally you would expect to see variances in the accuracy across the ranges. So you expect to see the higher ranges get worse, for example, or the really low ranges get worse. So I'm quite surprised it's got a standard accuracy across the whole lot. I've only got millivolt ranges, so yes, okay. Volts and millivolts. Millivolts does have a high error percentage, so that's not surprising. AC volts the same. AC frequency response 40 Hz to 1 kHz. We can test that later on. We'll check this on my calibrator. We'll do a quick look at it here on the bench, and we'll put it on the calibrator and we'll run it through its paces on that and see how accurate it all is on that. Resistance ranges up to 250 meg. That's nice. See if we can actually do that. Capacitance. I've got some capacitor standards here, things like that, so we can check it on those too. Frequency ranges up there. Yep, up to 2% in that lowest range. That's because this is like closer to DC. It's not too surprising that it's got a greater error ratio there. And internal resistance specs. So 0.1 milliohm to 200 ohms, up to 100 volts, plus and minus. So polarity does not matter. That's nice. Internal meter calibration. So you can calibrate it, I'm guessing. Right, that's the boring bit done. Now I'll catch you long enough. We should do a screen peel. You know what you say here on the Defpom channel? Don't turn it on, do a screen peel. Oh yeah. Satisfying. Obviously I just made that up because I never said that before. So, let's turn this on. Do we have power? Screen is not very bright, even to me actually. My lighting is bright here, so it really doesn't help. Angles are good though, it's not bad. Angles aren't too bad. Certainly reasonable. Nice, it's actually got dual display as well. Let's get a better shot of this. So what I think I'll do first is go to the menu. Let's see if I can make this backlight any better. Backlight's already 100%. Right, so the brightness of the display is not really that impressive to me. It looks worse on camera. I mean, if I look at that, it's probably more realistic to what I'm seeing. Calibration shorts, okay. Short and open. Restore. About. Version 106. Hold it down again. Yep, okay. So this is multimeter mode now. DC, AC, hertz, volts, millivolts. So let's push that. What's it doing? So millivolts DC. AC with hertz, that's dual display, which is nice, that's what I'm saying. AC millivolts is what I had before. So we've got functions. So resistance function. Continuity tester, we'll check that for speed as well. Got my speed tester from Ian Johnston, I'll check that. Diode mode, we'll check that to see what voltage it puts out. And capacitance mode. Temperature. So cold junction 22. There's actually 3 degrees different to what my bench meter's saying. I'm not sure which one's wrong though. It could be a bit of both. And back to resistance again. If I hold it down, what happens? Nothing. Okay. So that's auto modes and that's manual modes with secondary functions. Yeah, okay. Range, speed, recording. I do like the graphing on here actually, that could be useful. So that's manual ranging. It's denoted by the dots moving across. That's auto mode. Okay. Hold it down. Nothing. Okay, nothing. That's saying you get menu and hold it down. Okay, let's hold this one down. There we go. This is a bit of battery internal resistance mode. Now, I did see another unit which did this colour changing thing between modes. Was it a Finercy one? I think it might have been. Can't remember. And the display looks very similar actually to that other one. It's red because it's not within a certain tolerance. So you can set the tolerance for the battery voltage. So if you're doing like sorting, batch sorting, you can set these up. So you can set the maximum resistance, minimum resistance, maximum voltage, minimum voltage. So if you're trying to sort a whole bunch of batteries, like 18650 or something to make a pack, you can set these tolerances up, give you a green screen. It will probably go green instead. That's my guess. This one, there you go, speeds in that mode. Holding it down does recording apparently. If it says so. I don't know. And that allows you to set these going into the menus. Right. Back? Yes. Right. Okay, so if you want to change that one, you'd be selecting there, push that, then you could change the values. Let's hook this up to something and try it out. So I've got this old battery here which I salvaged out of something. I replaced the battery pack. I actually put 2 new batteries in it. One battery was dead, one was still serviceable. So this is that battery, which is why it looks so bad. Let's hook up to this and see what we get, shall we? It's been sitting around for a while, so I could have dropped the volts a little bit. There we go, 13 volts is still fine. It's measuring 15 milliohms, also not looking too bad. What did the manual say this little thing should be? Let's have a look. There was that chart in there. Yes, a lead acid battery, VRLA, 2 to 10 milliohms. Well, we're outside of that. Capacity based. Now this is a 22 ampere, I think it was. Yeah, 22 ampere. which should be, according to this, about 10 milliohms, according to this chart as well. According to this is out of spec. And it wouldn't surprise me because it's quite an old battery, but it is still working, and it does actually handle a bit anyway, but it's good for doing testing with. So that is actually working, and you can see that this has changed colour. That is still red because we're obviously outside that spec. Can we change these? Yes, we can. Let's go up. There we go. Now it's gone up by 10. It goes white instead of green. That's fine. This isn't red anymore. So that works. No issues there. Let's reverse polarity. So what happens, shall we? The manual seemed to show that it could do it. Probably got some dodgy connections. There we go. 13. Yep. Both directions look about the same. So that seems fine. That seems to work alright. Now this 4-wire connection on here, it's like a collar. You have to pull back. The problem is when it goes into here, it's a recessed panel. So trying to grab hold of that to pull it back out again with my fat fingers, it's actually really hard to grab hold of. That's the only way to release it. You have to pull that collar back. Wish it wasn't quite so recessed. So this thing claims Cat 3 and Cat 2. I'm always sceptical about that, especially when your wires are so thin. So let's do some tests with this. These probes are part of the Cat ratings, these covers. Right, let's see what we get. Guess I have to do manual modes, do I? So I just want to see how quickly this responds from an open to a short. It's not too bad. I've certainly seen worse. It's not too bad. Next thing, continuity, basic tapping, then I get my tester. That's actually pretty quick. Now these probes are not clean yet. They've got some coating on them. So once you get through the coating, it's fast. But just touching them together isn't necessarily good. So let's give these things a clean up and we'll try it again. That usually increases the speed. It is latched, so it's missing some. It's also graphing it as well. It's graphing something. I'm not quite sure what it's doing actually. So let's get my tester out. There's a DMN continuous tester for my in Johnston. So we'll turn this on. And it's not getting them all. Let's set this up so we get an every pulse. 20 milliseconds. 16's missing the occasional one. Yeah. 20 milliseconds seems like the fastest. Okay, 50 milliseconds seems reliable. What do we get to actually see something on screen? I was starting to see something there. Occasionally doing something. Not reliably. Nah. This is a common thing though. Very few can actually show anything on screen for these. It's just, yeah. That's at 250 milliseconds. We get the idea. It's a little bit slow. My fastest one can do it in less than a millisecond. My next test is to check these standard capacitors here. Let's go to capacitance. Now, lead spacing. This is something which is often mistakenly done by cheaper manufacturers. I'm looking at you for Nursey. That is perfect. That is bang on. Yep, that lines up perfectly. That's exactly the right spacing. Happy with that. Which means my 200 picofarad cap should be able to plug straight in. Like that. Can it measure it? It can. 222. No worries whatsoever there. Perfect. So the next one here is a 1 nanofarad. Yep. It's out a bit though. It's out by quite a bit. Let's check the next one. This is a 20 nanofarad. It's out by a fair bit there too. Not too bad. And this is a 1 microfarad. That's looking really good actually. Look at that, it's bang on. That one's good. So that's alright. This 1 nanofarad, I thought would be better than that. Try it again. Yeah, that's quite a way out. It's like 7% out. I think that's out of spec. Right, let's have a look and see what the diode output is. The actual diode voltage. Plug that in there. Change to diode. Diode mode. And we're getting 3.26 volts. That's good. That's a nice voltage. That'll do most LEDs. In fact, I think just about all LEDs actually. So that's good. Sometimes only like 2.5 volts, and that's a bit marginal. At least you can do like white LEDs with these things. So that's good. So here's that temperature mode. Let's have a quick look at that. As far as accuracy goes, I mean, I do actually have a tester here. Rattle, rattle, rattle. I do actually have a tester here which will allow me to actually simulate the thermocouple. I'm not going to worry about that though. I rarely use that thing. It'll probably take me longer to figure out how to use it than anything else. Alright, thermocouple plugged in. Let's have a look. Temperature, it's in here somewhere, there we go. It's measuring 27. My bench meter says 25.4. Okay, oh, it's 26 there now. Let's take this off because I was touching it before. And with cold junction there's also 26. I'll put it in backwards. Does that do anything weird? Sometimes it does. 25. Doesn't seem to care. So the thing with that sort of makes you think, well, if you plug that in, how do you know it's actually working if you've already got a screen temperature? Well, let's plug it in again. Touch it. Does it go up? It does. So yeah, that's working. So I think the only thing left to do right now, apart from taking it apart, which we'll do afterwards, is go to my calibrator. So to the calibrator. So here we are at the calibrator. It's my Datron 4700. This does resistance, voltage, frequency, with AC of course. So I'm going to start with microvolts, see if we can see this DC microvolts. Turn the output on. It's doing 100 microvolts. Nothing showing up. 1 millivolt. Yep, you can see that. A couple of counts out, but it's there. Only a couple of counts out. It's actually looking pretty good. 100 millivolts. It's bang on. Accuracy's looking good so far. 1 volt. 4 counts out. That's still well within spec. 10 volts. 9 counts out. It's still within spec, I think. 100 volts. 6 counts out. That's not too bad. And it is graphing our steps we're doing. Now, I don't remember what the maximum voltage was on this. It says 1000 volts on the front there for Cat 2. Let's see if we can do it without blowing up. So, let's wind this down a bit first. Go ahead and let's scale up. 300 volts. Looking good. 500, yep. 700. Couple of counts out, not too bad though. Looking pretty good. 900 and 1000. It didn't go bang, so that's good. There's only a couple of counts out. That's pretty good. I'm happy with that. So let's do AC now. Actually, this has got a DC millivolt range, doesn't it? Let's look at that before I go back to AC. I didn't actually look at the millivolt range. Yeah, that one there. Maybe that'll show better these low levels. Let's try that. So 1 millivolt, here we go. That's showing up nicely actually. A few counts out. And 100 microvolts. Yeah, that's good. And it's 6 counts out or so. It's actually not too bad. It's doing pretty well. And 10 millivolts should be, you know, probably scaled up. Yeah, there we go. So that's all fine. So yeah, that's good. Right, now we'll do AC. So it's 10 millivolts there at 100 Hertz, and it's seeing 100 Hertz just fine. It's also seeing the 10 millivolts just fine. Let's try 1 millivolt. I wasn't expecting that to see that. You can see 1 millivolt as well at 100 Hertz. That's actually really good. Okay, let's do 1 kilohertz. Yeah, you can still see that just fine. Can't see the frequency though. Yep, 1 kilohertz, yeah, 10 millivolts. So that's really good, you can see it quite well. 100 millivolts. I'll stay at 1 kilohertz for the time being, and let's see how we go. Then we'll check some frequency limits once we get to some higher levels. So 100 millivolts is looking good too. Actually, just change to 100 hertz, just to make sure there's a fair reading there. Yeah, that's looking good. That's 100. That's 1K. So 1 volt. It's on millivolt range still. Take out that. Standard AC range. 1 volt. That's out by 56 counts. That's significant. There's still 100 millivolts on this mode. So 100 millivolts on this range is now reading low, and 1 volt is reading high. That's interesting. Let's try 100 hertz. Closer. Okay. 10 volts. Set 100 hertz. 15 counts high. Not too bad. Certainly reasonable. I mean, for most people, it doesn't really matter. And at 1K, it's also the same. So it's like in a 10 volt range, a lot more. While we're at 10 volts, let's change some other frequencies and see what we can actually get out of this. See what we can do. 10 volts is a nice strong level for it. I might even do it 1 volt. 10 kilohertz. Can't see it. So I can see the frequency but can't see the voltage. That's an interesting one. Let's do 1 volt. Can still see the frequency but can't see the voltage. So 10 kilohertz is outside of the bandwidth of the AC, but it's got an internal frequency counter which can see it. Just to confuse things. Let's go a bit higher with this. 20k, you can still see it. 30k, yep. It's ranging up. 40k. Can still see it but struggling a little bit there. 50 kilohertz. No, I can't see that. Go to 10 volts. I bet you'll be able to see it now, can it? There we go. 10 volts, so you can see 50 kilohertz. 70, yep. 90, yep. 100. Still see that at 10 volts, that's good. Keep going. 200, yep. I don't know what the specs said it could actually do. 300, ranging up again. 400, you can see that. 5, yep. 7 is struggling with. 600 is struggling with. So I think 500 kilohertz up to 10 volts and about 10 kilohertz at 1 volt. That's that kind of profile, I suppose. So let's go back down to 1 kilohertz, I think. So back to 1 kilohertz, 10 volts, that's fine. Okay, let's go higher. 100 volts AC. So 100 volts AC, 1 kilohertz. That's shown up just fine. Let's go to 100 hertz. Looking just fine. Let's go lower. 50 hertz, typical line frequency. Looking fine. 20 hertz. Yep, still fine. It's actually good. 10. Some things struggle with 10 hertz. You can see it's bouncing around a little bit now, but it's actually doing quite well. But that's at 100 volts. Let's go down to 10 volts again and see what low frequency we can get out of this. So 10 volts, it should be able to see it. You can see it. That's good. So 10 hertz, it's working, but you can see it's jumping around a little bit. Like I said, it's not surprising. 20 hertz just stabilise it a little bit. Yeah, it is more stable. So that's fine. Okay, let's do a higher level. Back to 1 kilohertz and the 1000 volt range. So 100 volts again. 200. Can I bring this up a bit slower? Peak voltages are usually like 750 volts the maximum. Still not looking too bad. Only a few counts out there. 700. 800. There we go, over range. So 750 is quite commonly the maximum. This is looking like it's going to go a little bit higher than that. 780. Okay, so maybe 800 is the maximum then on this one. 799, yeah. So 800 would be the max on this one. That's fine. But that's working alright. So now we can do resistance. I've got it set to a short right now, so we're getting 0.4 ohms through the leads and through the calibrator. It's not completely nulled out. If I had a short on here, it'd probably change. Let's put a short on there. There we go, it's dropped down a bit lower. So we've got some resistance for the calibrator and stuff. I know about that, that's completely normal. That's okay. 10 ohms, 10.46, 10.42, perfectly reasonable. A few counts out, nothing wrong with that. 100 ohms, just 0.42, 0.49, 0.5, 8 counts out, that's not too bad. Don't forget about lead resistance will be playing a factor in this, because it is only 2 wire. 1K, looking pretty good. 0004, 0006, only a couple of counts out. 10K, 002, 003, that's 3 counts out. Certainly well within spec. 100K, we'll call that bang on, shall we? Rounding, that's looking pretty good. 1 meg, give us some time to sell. When it gets these higher resistances, setting time is important. So, yep, that's looking okay. It's 7 counts out from this. Reasonable. Don't forget, this is supposed to be able to do 250 meg. 10 meg. Bang on. No worries there. 100 meg. Give us some time to sell. Yep, it's only a couple of counts out. Maybe 1 count. Oh, there you go. It's made it now. It's probably my hand in proximity though. Yeah, my hand being close to it is inducing noise, which is triggering the reading to increase. We'll step back a bit there. Here we go. It's 1 count out. I think that's perfectly fine. Can't complain about that. Right, next thing. Let's take the thing apart. Let's have a look inside it. What is in here? So there's supposed to be a 2000 mAh battery in there. So we expect to see that. These are self-tapping screws, but that's fine. You know, it's not something you normally need to get into. As it doesn't have a current range, fusing is likely to not really be an issue because there's no fuses. Okay, so that's that part. I guess the front here comes off. Here we go. It's a bit more forceful. Okay, there's a battery. So unplug it. Oh. That didn't unplug very well. Surface mount connectors. Whoops. It's got glue on there. I guess I knew this was going to be a potential issue if someone unplugs it. Yeah, I guess I'm going to have to fix that. Oh dear. Where was it plugged in? Over here. There we go. Just there. Yeah, that's easy to fix though. Whoops. At least it's actually marked the positive side as well. It's actually really soft glue. Well, that wasn't quite the start I was hoping for. Anyway, that's easy for me to fix. So if you've got one of these things, don't unplug the battery. Let's see what this battery actually is. Just want to find out what this battery actually is. Just to be sure that it is what it claims. I mean, I expect it is, but you never quite know, do you? At least you know for sure if I have a look at it. Yep, 3.7 volt, 2000 mAh. No issues there. Date of June this year, so yep, brand new battery as well. It's not old. Put that back in. So I've got some Chongx caps in here, which I mean a lot of equipment these days. So I think the brand Chongx is actually okay-ish. Yeah, certainly not rubbish caps. Obviously not the highest quality brand, but they seem to be moderately okay. A lot of manufacturers are using them. I don't think it's because they're rubbish. I think it's because they're reasonably priced. I haven't seen any real failures from those yet. They seem to last okay from the equipment I've seen anyway. So I don't really have any real issues with these particular caps. At least it's a brand I've actually heard of. So here's the riser adapter here for that socket. So they could have actually not had that recessed by so much and put it straight in the main board, couldn't they? Yeah, they could have put it straight in the main board and not actually had it recessed at all. So they're actually caused upon by recessing it. That's pretty interesting. Standard jacks here, just folded, nothing special. Got a PTC sitting just here, a little bit of protection. Switching relay for something here. Chip, which is not hidden. Bunch of diodes and stuff. Anyway, let's get closer. Maybe get some numbers or some chips or something. 4036. MX4036. That number's familiar. Don't know what those are. So RS8552, I think that's what it says. These things here. Some MILFs. Everyone likes a bit of MILF. DM1109 CEN. Is that a custom chip? Or at least custom marked. Certainly not standard markings. It's obviously their processor. Not sure what that thing there is. T1. Okay, transformer. Interesting. And there's those other diodes up there. M7s. Okay, standard shotkeys. What's that? BL1555. Another RS8552. Oh, that's an op amp or something. Artery. What's that? OT32F. Oh, that must be the main processor there. And there's a programming header. Little buzzer, little screen flex going there. 4 MHz crystal. Seemingly another programming header. So it's probably got two processors then. That one there, which is custom, and this one over here. Interesting. What's that device there? ICL 8069. I don't recognise that. The fact that that pulled off the board so easily worries me a little bit about this one. I don't like surface mount sockets like this. Not when you're relying on basically the adhesion of the traces to the circuit board. I don't like that sort of thing. I prefer them to be screwed on. Got pins going through which are melted on the other side to hold it. I don't know, but I've seen plenty of sockets where they are surface mounted and just come off the board like this one just did. So I need to fix that. Anyway, that plug was really hard to get out of this socket. It was really tight. I had to get into tweezers and try and force it between the tops of the plug there and the side of the socket to try and basically wedge it out. That was really hard to get out. It's not surprising with the circuit board. There's no way I would have been able to unplug it without damaging it. Anyway, I'm going to clean the pads off this. Just fix this. Just do a little repair. Got a solder iron, bit of solder wick. Let's see if we can do this without any putting an extra flux on anything on. Let's see if we can get this out of here. Clean this up. I may need to put flux on or some fresh solder. We'll see how we go. So I'm going to see if I can do it without doing that first. That's fine. Next piece. Get in there. Okay, that's good. Let's put some fresh solder on there. Or shall I? I might be able to flow it in from the sides. Let me have a close look. I'm going to float it in from the sides. I'm going to be using leaded solder. So I'll put some leaded solder on one side so I can anchor it straight away. I'm going to use this just a little bit on one side and anchor it down. There you go, there's enough there to anchor it. Okay, that's down. Legs kind of line up, kind of. I'm slightly offset to one side. Let's move it over a little bit. Okay, happy with that. Not perfect, but it's close enough. Let's do this side, then I'll anchor down the pins. Try and do it so you can see what I'm doing as well, maybe. Kind of see, can't you? So try not to melt the socket. Okay, looks like it's anchored well enough. Go back to this side again. I'm not sure it's actually flowed well. I can't really see it too well. It's looking a bit weird on my lights. Yeah, it's not really flowed onto the pin. I may need some flux here. Oh, there we go. That's done it. That's better. Okay, now it's to the pins. Here you go. It kind of works. Right. Let's just shove this in here. No flux. You can probably see this better than I can right now. Flux would make it look nicer, but I want to minimise cleanup. It's going to use cotton bud because it's only a small area. But this is only because that socket was so tight on that plug. Now if it hadn't been that tight, this wouldn't have ripped off. So, but this isn't really something you'd be doing. I think if you're pulling this thing apart, you shouldn't need to pull it apart for any reason whatsoever. There's nothing in here for you to deal with, or no fuses or anything like that. Maybe if you want to replace the battery in the future, you want to do it, but I think reality is that's not really likely. So, okay, let's have a close look. Is that clean enough? Like I said, you'll be able to see better than I can. It's not too bad. My soldering's not perfect, I've got a bit of a spike on it, but I don't care. It's good enough. So before I forget, don't forget to click like and subscribe, just like it says on my desk. Alright, let's plug this back in again. What could possibly go wrong? Plugged in nicely, like no stress whatsoever. Oh, interesting. Got those little support posts on the back there too, which is interesting. Drop straight back in. I'm going to repeat this again in case you've never seen me mention this. When you're putting any self-tapping screws in like this into plastics, wind it backwards until it goes click, like that, then put it in. That way it drops into the original thread. You're not trying to cut a new thread and chewing the threads out, or chewing the plastic out with the new threads. Each time you put a screw in, you cut a new thread, unless you drop into the original one. Like that. Just a good thing to do, good technique. I mean, lots of people have mentioned this, but you may not have seen that mentioned. Right, let's turn it on. Does it still work? It does still work. Yay. Brilliant. It's not dead.
I'm not dead! Yeah, he says he's not dead.
So once again, thanks a lot ZOYI for sending this to me at no cost. Hope you found the review interesting. I've got loads of other reviews, lots of things I reviewed in the past and continue to review. So there's video links down below to those sorts of things. There's be playlists for reviews. I've got loads of stuff. I've reviewed lots of products. There's also a subscribe link over here. If you're not subscribed to the channel yet, make sure you do that to see future reviews or see me repairing things like I just did with this, or better. And there's a Patreon support link over there. If you want to help support the channel, donate to the channel, you can give me a tip, and that contributes to the channel. A couple of dollars a month is all it takes. Get enough people give me a couple of dollars a month, I can buy a lot more equipment to do videos about. Thanks for watching. Catch you later.